assessment 4, and the question states that, like, you and a friend with holding a wet clay about 30 grams each, you throw it up in the air with the first object with the velocity of 3, 3, -3, and the object 2 with the velocity of -3, 0, -3. So the first question states that, what is the total momentum of the lumps just before impact? For that, I use the momentum formula, which is mass times velocity, and since there's two velocities, what we have to do is m1 v1 plus m2 v2. Since the mass is constant, I pull the mass out. So in that case, momentum is equal to mass times v1 plus v2. So for the mass, it's 30 grams. Since I need it in kilograms, I divide it by 1000. So I have the value 0.030, and if I add the vectors up and multiply the mass, I have the value 0, 0.09, negative 0.18 kilograms meters per second. For the second question, they're asking what is the momentum of the stuck together lump just after the collision. So for that, I have the same answer because according to the momentum conservation principle, collision of two objects in an isolated system, the total momentum of the two objects before the collision and the total momentum of the two objects after the collision equals the same. So the momentum lost by the object 1 and the momentum gained by the object 2 equals the same. So we have the same value 0, 0.09, negative 0.18 kilograms meters per second. So the third question is what is the velocity of the stuck together lamp just after the collision? For that, I use the formula momentum is equal to 2mv. So since we need velocity, I divided 2m from the velocity. So velocity is equal to momentum divided by 2m. So for the momentum, I just took it from there, which is 0, 0.09, negative 0.18 divided by 2 times 0.030, which is mass. When I did all that, I have the value 0, 1.5, negative 3 meters per second.